welcome to T Maths, and today we're going to continue with our Laplace transform for trigonometric and hyperbolic functions. So we start with sines and cosines. So let the function g of t be sine 80 and the function f of t be cos 80. We want to find the Laplace transform of sines and cosines, and we start immediately by taking the Laplace transform of sine 80, which we all know by definition is integral from 0 to infinity of sine 80 e to negative st the t, and we can call this capital G of x. And then the Laplace transform of cos 80, which is integral from 0 to infinity cos 80, we'll call this capital F of x just to minimize our writings. So we'll start with the first one for sine 80. So we'll have our g of x, which is Laplace transform of sine 80. This is simply 0 infinity sine 80 e negative st the t, and if you remember integration by parts, where u the v is equals to uv minus integral of v du, and let sine 80 be our u and e to negative st be our the v. So u is sine 80, which implies that the u the t is going to give us a cos 80, and then our the v, the a be e minus st, which implies that our v, which is taking the integral, is going to give us negative e minus st all over s. So applying this integration by parts, our g of x will give us uv, which is sine 80 dot negative e to negative st over x. We'll put the limits, then minus v du integral from 0 to infinity our v negative e negative st all over s, and our du a cos 80 the t. Alright, so but first of all, let us try and simplify this. Let's simplify the first term. So this first term, if you apply the limits, this is simply going to give us, when t is infinity, we have sine a t, which is sine a infinity, which is sine infinity, minus e negative infinity all over x. Now, okay, there's a little error here. This should be able to just multiply. I can bring out the sign, the negative sign up here. So this is minus, then when t is 0, you have sine 0 dot negative e 0 over s. So if you look at this, e to the negative infinity, we already established in our previous video that this is 0, and 0 times any term is 0. So this is 0 minus, what about the sine 0 is 0, so this is also 0. So this whole term is equals to 0. So this entire term is just 0, so we can skip it. So we have our g of x to be this term here. So I'm going to rewrite it for clarity. So g of x is negative 0 to infinity negative e negative st over x a cos 80 the t. And from this you can see we can pull out this negative sign, we can pull out s, we can pull out a, and if we do this, we're going to have negative a over x, and then we can bring the cosine in front. We'll have cos 80 e to negative st the t. And negative negative is positive, so we have this is positive, and we can easily take that off. We don't really need that there. But then take a look at this integral. What exactly is this? Let's go back up to where we started. You can see that that is the same thing as this integral here. So what we have there is simply f of x. So this is just f of x. So that means our g of x is equals to a over x f of x. Let's call this equation 1. Then let's solve for f of x, which is f of x, which is the integral from 0 to infinity cosine at e to negative st the t. And here again we apply the rule of integration by parts, which I'm going to write again, v du, and here let our u be cos at and let the v be this. So if our u is cos at, this implies that our du is going to be negative a sine at. And then if our dv is e to negative st, this implies that our v, by taking the integral, we're going to have negative e negative st all over x. So if we apply it here, we'll have that our f of x, which is this, applying it to be in this form, we're going to have our uv, our u here is this, so we're going to have negative cos at e negative st all over x. We'll put the integral, we'll put the limits minus integral v du. What's the v? Negative e negative st over x, and our du is negative a sine at the t, and we have to put the limits of the integral. So once again, just as we did previously, we're going to evaluate this to make our life simpler. So if we evaluate this with the limits, we're going to have this to be at infinity. We're going to have negative cos at, t is infinity, so it's just going to be negative cos infinity, that's e to negative infinity all over x minus, okay, when t is 0, minus cos of 0 e to the power of 0 all over x. And if you evaluate this, you can see that e to infinity is 0, as we know, so this whole term is 0, right? Then minus minus is plus, so we have plus cos 0 is 1, this is 1, and this is also 1, so we just have plus 1 times 1 all over x, so this is just 1 over x. So we've simplified this to be 1 over x, so we just have, so our f of x will just be 1 over x, and from here we can easily pull out our negative a, our s, and then this negative sign here. So we have negative negative a, which is positive a over x. We can pull it out, and I believe that makes sense, right? This will be negative negative a over x. We can pull this out, which is just pulling out a over x, right, from this expression. So if we do that, we're going to have our f of x will be 1 over x, then minus a over x into the integral from 0 to infinity. We can write it sine first, sine at e negative st the t. And guys, what is this? This is what we defined as our g of x, right? If we go back up, that's what we defined as our g of x at the beginning. This is it. So this is our g of x. So with that being said, we found that our f of x is 1 over x minus a over x g of x. And we already found earlier that our g of x in equation 1 is a over x over plus f of. So our g of x is a over x f of x. And we can just do a simple substitution here. We can substitute the value of g of x as this into this equation. And if we do that, we'll have that our f of x, this is just algebra guys, 1 over x minus a over x into a over x f of x. And this is same as 1 over x minus a squared over x squared f of x. If we take this term across the equal sign, we're going to have f of x plus a squared over x squared f of x equals to 1 over x. And this is same as f of x 1 plus a squared over x squared equals to 1 over x. And this will simply give us that f of x into x squared plus a squared over x squared equals to 1 over x. And from here we can divide both sides by this term. If we divide this side by the term, we just have f of x. And if we divide the other side 1 over x by this term, we're going to have 1 over x times x squared over x squared plus a squared. And as you can see, this is x squared guys. X will cancel this and we are left with that our f of x is equals to x over x squared plus a squared. And what is f of x? That's the Laplace transform of cosine at, which is simply x over x squared plus a squared. Alright guys, now let's to find what our g of x is. Recall that our g of x is just a over x f of x. So our g of x, which is a over x f of x, this is simply a over x, and our f of x is x over x squared plus a squared. This cancels out and we're going to have a over x squared plus a squared as our g of x. And what is g of x? The Laplace transform of sine at, which is a all over x squared plus a squared. So with this, we've been able to establish that sine at, Laplace transform of sine at is a squared, a plus x squared, is a over x squared plus a squared. And that of cos at is x over x squared plus a squared. Alright guys, so let's keep this in mind. We're going to solve a lot of examples that involves the Laplace transform of trigonometric functions. And next we're going to go into hyperbolic functions in the next video. Thank you guys. Please do subscribe.